finishing today's lesson. All right. The lesson is on recursive functions and data. All right. Where is it?
Bruh. Just scroll.
No, it's like not on it.
It's extended monitor, so move it all the way to the right until we can see it on the whiteboard.
You moved it too far. Come back a little. There you go.
Oh,
No,
gosh.
no.
There we go. Oh, okay. There we go. All right, example of recursion. Reading lines from an input file and printing them in reverse order. All right, let's assume that the input is this. Hello, this is Tony. The output should be Tony is this hello. Now, how can we do this without recursion? Public static void reverse scanner input. All right, so that is a method, but how do we know it's a method? Anyway, we're reviewing for the AP test. Public static void, so does it return anything? Everyone?
No.
No, exactly. What if it said double instead of void? Would it return something?
Yes.
You guys are so good. All right. So the lines in the file can be and getting participation points. Reverse print solution. So public static void reverse if not scanner. Why is it not?
Because the exclamation.
Exclamation point. Exactly. So base case and the file return. Else statement. Recursive case. And then string line scanner dot next line. So whatever the user types next will be the string named line. Then reverse scanner. So we know that this is recursive because it's calling the method that it is. So like the name of the method is reverse and it calls it again here. So because of that, we know that this is an example of recursion. Then it prints out line. What data type is line?
String.
String, exactly. And is that an object or a primitive type?
Object.
Object, yay. All right. Yes.
So why would you want to do not scanner?
Uh-oh.
All right.
Save the questions for the end,
You know,
please.
exactly, yeah. So I think it'll become more explanatory. All right. So to reverse a sequence of lines, simply read a line, reverse the remaining lines in the sequence, and then write out the line read. All right. Yes.
Why would they want to like reverse stuff? Like, so it said like Tony is not or like whatever. Why would I ever want to do that?
That's just an example. That's not like an actually applicable thing. Like why would you,
applicable.
wait, like why would you want to print out a bunch of stars from like unit 1? You know, like these are like.
That's not the question though.
No. I'm using another example. Like
It's because there's a stack. Because if you go like Tony, this is the whole thing. Because it's gonna go like a stack. So then if you want it reversed.
are you saying when would this be like a real?
Yes.
Yeah. So let's say you have a list of names and they're in alphabetical order, but you want to reverse it, so it's all the Z's first, and then you go to
Oh,
A.
it's just like flip. Okay.
Yeah. All right. That was a great question, guys. Hi, James. You were late, but you can make up for it with more participation points. All right. All right. Also, Mr. Yan, you need to participate too. Like. All right. Reverse print revised solution. So base case is very simple. We can change the condition check to eliminate it. Public static void reverse scanner. If scanner, string line equals scanner, reverse scanner, system.out.println line. So you might be wondering, how does this work? I will refer you to BJP book, page 754 to 750.
I didn't even know we had a book.
Yeah, Mr. Yan, see, this is why you need to teach like me. See, now I tell you that there's a book. It's like in the files from the first semester Canvas. All right. More recursive functions. How?
What does PAL stand for?
We're getting there. No, you don't want to spoil the surprise. All right. It stands for power. All right. Recursive functions. Integer exponentiation. N to the power of n. So n would be the power there. Provided in Java by math.pal my. So which letter here is the exponent when you use it like that?
Wow.
Why? Exactly. Kind of clap for Mr. Yang. All right. So yes. Now, how can we implement this function using recursion? Does anyone have any thoughts, any predictions?
Make the end extra.
All right, any more predictions? All right, it's fine. You can think in your head. All right, so right now we're going to do a mini exercise. Write a recursive method, how xy, that accepts an integer base and exponent and returns the base raised to that exponent. Example, how 3, 4 returns 81. Why does it return 81? 3 to the power of 4, exactly. So solve the problem recursively and without using loops. Guys, I'm nice. I'm not going to make you take out any paper.
So it gives you the number, and then you have to...
You have to raise to the power, but we're using recursion this time instead of doing it this way. So yeah, like I said, I'm a nice teacher. I'm not going to make you take out paper, but like just think about it, all right? Yeah. All right. So here's the solution. We're not going to sit here all day while you think. All right. So it returns the base to the power of the exponent. The precondition is the exponent has to be greater than or equal to 0. Why does it have to be greater than or equal to 0? Anyone? Guys, why does the exponent have to be greater than or equal to 0? Yes.
Because we're returning an integer.
We're returning an integer, exactly. So, wait, what?
if the exponent was less than 0, then it would just give us a fraction.
You're absolutely
and that wouldn't be right.
Yes. All right. Oh yeah, because like a negative exponent is 1 over that to the power. Yeah, guys, clap for Evan. That was like really impressive. All right, like everyone better participate like Evan. All right. So public static int how. So it's taking in 2 parameters in this method. What primitive type are these parameters?
Integer.
Integer. Guys, we're reviewing for the AP test. Like unit 1 stuff will come back. All right. If the exponent equals 0, why are there 2 equal signs? What happens if it's only 1 equal sign?
Syntax error.
You're assigning it. And would that be a runtime error or a compile error?
Compile error.
Compile error. Why? Because it won't compile properly. Exactly. So also guys, just for some people who might not have noticed this, these green lines are comments. And when you have these 2 slashes, it makes something a comment. But there's 2 other ways to make a comment. What are those? Slash star, and then you need to close it with a star slash. Exactly, yeah. Good review. All right, so return 1. If the exponent is 0, because anything to the power of 0 is 1, right? Else, return base times how base exponent minus 1. Now this works because it's basically saying that something to the power of a number is equal to that number times that number to the power minus 1. For example, like 3 to the power of 4 is equal to 3 times 3 to the power of 3, right? 2 to the power of 10 is equal to 2 times 2 to the power of 9, right? Does everyone understand why this works?
Yes.
Awesome. And this is recursion because it's calling the method that it's in. All right. And we talked about why this is method.
So how is it like? So we talked about like recursion is like office, like right? It like lists it.
No. That was that one specific example. So we wanted to use recursion to reverse the list in that one example. But you can have many other recursive methods that don't do that. Yeah.
Can you like draw it out?
I can definitely draw it out. All right. So, guys, I made this title slide for you all.
Oh.
Get that. All right. Yes. Wait, what do you want me to draw out?
I was thinking like step or like another loop.
Oh, yeah. I know exactly what you mean. All right. So yes, okay, someone give me an integer for base that we're passing through.
2.
No. 2. Yeah. All right, base is equal to 2. Exponent.
69.
29.
No. 3. Yes, thank you. You're all losing participation points. All
Am I
right.
getting there, Parsa?
Yeah, you
Thank you.
are. All right. So we have 2 and 3. So if exponent equals 0, is exponent equal to 0? Everyone?
No.
No, exactly. So it goes into the else statement. All right. So it returns base times how base exponent minus 1. So it goes through the loop again. This time, what's our base?
2.
What's our exponent?
2.
Exactly. Is our exponent equal to 0? So it goes into the else statement. This time, our base is 2. Guys, everyone has to participate. What's our exponent?
1.
1, exactly. Is our exponent equal to 0?
No.
No, so it goes in another time. What's our base?
2.
What's our exponent?
0.
0. Is our exponent equal to 0?
Yes.
Yes, so it returns 1 for that part. But we have to multiply all the bases by 2. So it's 2 times 2 times. Okay. 2 to the power 8. It returns 8. Yeah. So did everyone see that connection from this part to this? So basically, we have our base 2 and exponent 0, and we know that we're raising it to the exponent, so 2 to the power 3 is 8. Now,
I'll explain it because you did such a great job, but let me see if I understand it.
Okay.
Alright, so this one returned 1, right? So this whole time was 1. And then this whole, because this is a loop from here, this is 1 times whatever is here, which is 1. And then you're going to have to multiply it by a 2. So then this whole thing is equal to 2, and then which changed to this guy. So then it's 2 times this whole thing, which is 2, that's 4. This whole thing changed into this one, which is 2 times all of this, which is 4, and that's how you do it. So you don't have 2 times 2 times 2 times 2. This whole thing returns 1. And then 1 times 2 times 2 times 2, and that's how you get the machine.
Oh, gotcha. Yeah. All right. Okay, did everyone see that? This returns. Yeah. Just so that I can restate what Mr. Young is saying. This returned 1 times 2 times 2 times 2. So it's
Yes, we got it.
awesome. You know, sometimes the teacher learns from the students as well. You know, it's kind of rare, but it does happen. All right. Now we're gonna move on. Almost. There we go. All right, optimization. How many of you guys have heard this word in your math class? Like in Calc AB, we talk about optimization, pre-calc. What math are you guys in? No one's on optimization.
Wait, we talked about this in pre-calc?
Pre-calc honors at least linear optimization.
Yeah, that's
Evan
not
can't
me.
raise it. All right. So we're gonna talk about it now. So notice the following mathematical property. 3 to the power of 12 is equal to 3 squared times 12 over 2. Do we understand that part?
I get that.
Because they multiply.
Yep.
All right. 3, or which also equals 3 squared times 6, because 12 divided by 2 is 6. Do you understand how we got from that to that?
Yes.
Yes. All right. Then that also equals 3 squared to the power of 2 to the power of 6 over 2.
Which goes to 3.
Oh, I'm on this step right now. Understand this?
Yes.
Yes. All right. Then after that, this. All right. So we all understand this chain here.
Yes.
Awesome. So when does this trick work? Any ideas?
With recursion.
You're getting ahead. You're getting ahead. When does this trick?
prime exponent.
A prime exponent?
Yeah.
12's not prime.
Odd exponent.
Yeah. When you only have an even exponent, I think is what you're trying to say.
Don't have a prime exponent.
When you don't have a prime exponent. Alright. No, but like if you do 3 to the power of 3 divided by 2 and it's an integer, then won't it like, you know.
But that's not prime.
Okay, yeah, James, you are right. Mr. Yen, as a fellow student, do you agree with what James said?
I didn't hear.
When the exponent is not a prime number.
Exponent is not a prime number. You're allowed to break it up.
Yeah.
Well, if it's prime, then you can't. Yeah, you can't.
Awesome, Mr. Yan agrees. So, how can we incorporate this optimization into our PAL method? Does anyone have ideas? Does no one have like thoughts? Like you guys think?
Silenced me last time.
All right, I have an idea. In our PAL method, we can call that method inside the method and break apart the exponent one more time and then call it again. Kind of like what we did in the previous PAL example, where we kept going back with a new exponent. You know, Daniel, you missed the lesson. A lot of it.
Stay after class.
All right, yeah. You guys, you can always come to my tutorial. Like, I don't even have a closed tutorial day because I care so much about my students. But yeah, so guys, this part's really important. This is tying everything together. So listen up. The PAL method can be called with recursion by calling it again with a new exponent each time. So what is the benefit of this trick if the method already works?
There isn't.
All right.
Optimization. It makes it faster.
Yes, this ties into optimization. So in everyday language, guys, listen up, this part's really important. So what does optimization mean in everyday language? Like when we optimize something. Turn to your partner, talk for like 15 seconds. Thank you, Daniel. Talk to your partner. What does optimize mean? You have 5 more seconds. Talk to your partner. All right, time's up. Yes.
It makes it better.
Makes it better. Does anyone have a more precise definition? Efficiency. I like that word. Evan, do you have any thoughts for optimizing something?
It makes it more efficient and better, like they said.
Great. Efficiency and better. Those are great words.
I thought mine
And
was
that is-
precise enough.
Yeah, no, it's when it's combined with efficiency. It's
Oh,
better.
okay.
Yes. All right. That is great. So that's how we're optimizing it through recursion. All right. PAL solution 2. All right. So we're going to return base to the power of exponent again. We already talked about why the exponent has to be positive. So if the exponent is not equal to 0, returns 1. Else if exponent mod 2. Does everyone remember mod?
Yes.
I'm a mod master. Mr. Yen saw I did 105 extra practice problems in front of Mr. Yen when I missed that one question on our first test.
Oh my god.
And he never gave me that point back. Wow. All right.
I'm dead.
So yes. So if the remainder equals 0, that means that it's even. Then it returns PAL base times base and exponent divided by 2. We're going to go through it again on the whiteboard, so we'll make sense of this later. Else, it returns, so if it's not even, essentially, it returns the base times power of base exponent minus 1.
Oh, so the other
Yes. So this is an else if statement. This is just an else statement. Who knows the difference between the two? Reviewing for AP tests. What would happen if this just said else? Is there just no difference?
Because it gives it another condition that has to pass.
Exactly. Yes. So now we're going to go through it one more time. All right. So. All right. I'm just gonna leave it like that. All right. So. Mr. Yan, since you're on your phone, you need to go lift up. Guys, so clap for Mr. Yan. Thank you so much. All right, let's use 2 and 3 again because I like those numbers. All right, yeah, those are great numbers. So, thank you, Mr. Yan. All right, does our exponent equal 3? Or,
It does.
it does, yes. That means nothing. Does our exponent equal 0?
No.
No. So, is our exponent mod 2 equal to 0?
No.
No. So it goes into this statement. So it returns the base times PAL base exponent minus 1. So it goes through this one more time. What's our base?
2.
2. What's our exponent?
2.
2. Is our exponent equal to 0?
No.
Is our exponent mod 2 equal to 0?
Yes.
Yes. So it goes through this method one more time with base times base and exponent divided by 2. So what's our new base?
2.
4.
4. It's base times base. 2 times 2 is
4.
4. And then our exponent 1. So is our exponent equal to 0?
No.
No. Is our exponent mod 2 equal to 0?
No.
No. So it goes here, and it returns, or it goes through the method one more time with our base as 4, and our exponent as 0. So is our exponent equal to 0?
Yes.
Yes, and it returns 1. Now, Mr. Young, do the magic.
1 times 4.
All right, Omron.
Let's go.
No, say that. Just
Let him draw it.
Okay.
Yeah, let him go.
We have to start here, right? So it's 2 times tau is the base 2 and then exponent 1. So this is what this is going to return. So then we need to find this. So that one was returned 2 times 2. So that's a big sorry. That will return the power of 4, 1. So this one will go here. This one turns 4 times power 4, 1, right? And that's this, and this one, 0, which returns 1. So 4 times 1 is 4. So this becomes 4. Right, now that we have this, we can put that one into this one, which is going to be 2 times 4. I think, hold on. I lost myself.
Mr. Yang.
You're on the right track.
Hold on. Forgot to write a 2.
Where did I forget the 2, James?
The 2 times pow for 1.
Oh, there we
No,
go.
because it just returns POW 4-1. It doesn't return 2 times POW 4-1.
Okay, but
Yeah, it's all the
so
same between
4-1 is 4.
When you go into the else if, there's no multiplying part. It's just the
Yeah.
pow.
Right? Yeah. So you have to.
I didn't read that.
Well,
Okay, so the POW 4, 1 becomes, alright, when you run that,
Yeah.
it becomes base, which is 4 times POW 4, 0.
Yeah.
4, 0 is 1, so 4 times 1, you're correct.
Yeah.
So that whole thing is 4, is just 4.
Yeah,
and then, which is
4.
the same thing as POW 2, 2. So that whole
Yeah.
thing returns into POW 2, 2.
So this one returns into.
Yeah, and then 2 times 4 is 8.
Yeah.
So you're good, you're good.
Yeah.
Okay, that makes sense. Yay! Great job.
That would work too, but the bar might be
Alright. Omron did a great job, guys.
Yeah, I don't understand that.
I'll do another run through.
Alright, greatest common divisor. Does everyone know what that means? Like throwback to Math 6 Accelerator. Alright, we'll talk about it more in the next slide. So, greatest common divisor. The GCD is the largest integer that evenly divides into 2 integers. How do we, okay, let's think of some examples. Who has an example of a greatest common divisor? Of a number, just make up an example.
40.
10.
10.
Yes, 40 and 10.
Oh.
Any number.
Yes,
So basically would be 10.
as long as it's not prime, right?
You can have, well, that's 1.
Yeah.
You can have 1 prime number and 1 non. So it could be like 11 and 22, and the GCD would be 11.
Doesn't like any number divide into itself in 1?
Yeah. But
Isn't that not common?
Like why would a number's greatest common divisor not be itself?
both numbers
Because
can
that's just how it is.
No, it's the greatest common divisor between 2 numbers.
be 1. Yeah.
like 40 is 1 and 40, right?
No.
And 2 and 20, and
Yeah, there's like
4 and
No,
10.
you pick two numbers, and then you find the GCD of two numbers.
Oh, yeah, that's why. All right, so between 40 and 10, it would be 10.
Yes.
There we go. Between 25 and 5, the GCD is
5.
5. Yeah, okay, now we all get it. All right. So, public static int GCD, int x, int y. Throw back to last unit. If I took away the int part of this, what would this be?
Constructor.
A constructor. I'm just gonna give away the answer. All right, no, it would be a constructor. Yeah. All right, yeah. That would be a constructor. All right, we're gonna assume that x and y are not negative. So the approach is to eliminate any multiples of the smaller integer from the larger integer. We're gonna see this in the next slide. So, Euclidean algorithm. All right, yay! So here's the solution. Here is the recursive torus. You missed the lesson. You're good. You can always comment my tutorial, like I said. So here is the recursive solution, including the case of negative arguments. Guys, this is so exciting. Are you ready? Everyone listen up. So we have our public static int GCD takes in two integers x and y. If x is less than 0 or y is less than 0, so basically if any of them are negative, then it returns the greatest common denominator or divisor of the absolute value of x and the absolute value of y. We're gonna go through the examples with like numbers too, so if you don't get it just yet, that's fine. Else if y is equal to 0, it returns x. And all right, let's go through examples. So does anyone have a value for x? 10. All right. And a value for y? 5. All right. Those are great examples. So, are either of them negative?
Nope.
No. Does y equal 0?
Nope.
No. So we're going to go here. So it returns the GCD, or it goes back into the GCD with y, which is, what's y right now? 5. And x mod y. So what is the remainder when you divide it? 0. So now we go through it again. So are either of them less than 0?
No.
No. Does our y equal 0?
Yes.
Yes. So it returns x. Guys, this is our GCD. Yay! All right.
I get it.
And you can always refer to the textbook if you have any questions.
I think we should do one more.
What? Yeah. I definitely agree. Do you want negative numbers in this one too, so that we can try it?
25 and 10.
25 and 10. All right. 25 and 10. Are either of those negative?
No.
Does y equal 0?
No.
So it returns, or it goes back in. What's our y? 10. What is our x mod y? 5. Does everyone see how this is 5?
Yes, it's
Yes.
the remainder.
Awesome. Are either of those negative?
No.
Does y equal 0?
No.
What's the remainder? Alright, I did out of order, sorry. What's our 5? Yes.
Yeah.
So now it's 0. So it returns our x, which is 5. Whoa.
Thank you.
Guys, imagine if we had this in Math 6 Accelerator. It probably wouldn't help us. Alright. So yeah, I like this example better than like the other ones.
Yeah, you got the gears in my head turning.
Yeah, for sure. Alright. Directory crawler.
This is a beefy ass lesson.
This is the last one of the unit. Just push through this and we're done. Of this unit, yeah. Directory crawler. So, write a method what? A method called crawl that accepts a file parameter and prints information about that file. If the file object represents a normal file, just what's a normal file? Are we being fileless? Are there some like not normal files? All right, just print its name. If the file object represents a directory, print its name and information about every file directory inside it, indented. Do you see how I made that green? That was purposeful. indented.
Should I write it down?
If you want to take notes, feel free to. So, ABCS period 1. Yeah. Alright. We have handouts, syllabus doc, lecture schedule. What file format is that?
Excel spreadsheet.
Oh, right. Alright. So, homework. Yay. So, let's go to the next slide. So we can do stuff with this. Alright, file objects. A file object from the java.io package represents a file or directory on the disk. We have some constructors and methods. Do you guys want me to go through each one?
Yes.
Oh, alright. File string. It creates a file object representing file with the given name. The name is the string. So for example, file Evan. Evan is the name of the file. So, can read with parentheses. Returns whether the file is able to be read. Delete removes the file from the disk. Exists whether this file exists on the disk. Get name returns the file's name, which was the string, if you remember. So yeah, is directory returns whether this object represents a directory. Length returns the number of bytes. List files returns a file array representing files in this directory. Rename to file changes the name of the file, so I can get the Evan file and rename it to Parsa. Yeah. Alright. So let's do our first attempt without an indent. You guys know how much I love indentations, but we're going to do this one without the indent first. Alright. Private static void crawl1 file f. Why do we want this to be private?
Because you don't want the information.
Exactly. These are top secret files. We can't have just like anyone looking at these files. So if not f.is directory, not by the exclamation mark, then system.out.println f.getName. Else, this is the recursive case. System.out.println f.getName for file subfile. So this is a for each loop. And since this was an array, we go through each element of that array and we print the contained files. Now this is really important. This is a for each loop, and the only reason why we can use it is because we're not mutating anything. If this was a mutator method, then always make sure you use a full for loop just to prevent any problems. But since we're just accessing each and we're printing the contained files, this is why you can use the for each loop. Does everyone get that part?
Yes.
All right. So, public-private pairs. We cannot vary the indentation without an extra parameter. So public static void crawl file x string indent. Often the parameters we need for our recursion do not match those the client will want to pass. In these cases, we instead write a pair of methods. A public, non-recursive wrapper method. Okay, with the parameters the client wants. What's a wrapper method?
This is going to convert the type.
Converts the type. Oh, like it wraps it up in a new type. Alright, that makes sense. Wrapper method. A private recursive method with the parameters we really need. So is the public method recursive?
No.
Is the private method non-recursive?
No.
Good. just gotta reinforce some stuff, you know? Alright. Here's the solution. Was there a problem? Like, what is the solution for? Okay. So it prints the information about the file. And if it is a directory with any files inside of it. So public static void crawl file f, and then an empty string. And we have private static. So remember, one public that is not recursive. This one's not recursive because it doesn't call the method again. This is the private one that has recursion. So private static void crawl file f string indent system.out.println indent plus f.getName. If it's in the directory, then we do the for each loop and we print each part of the each file in the directory with the proper indent. Now we want those indents to be organized, right? So that our files can look nice and not be like unorganized. All right, you guys have homework, but since I'm so nice, you don't have to do it. So read these pages if you want. We don't. Did Mr. Resch really have a Google Drive folder for a student? Oh. All right, guys, that was the lesson. Give me 5-star reviews.
That was really
That was
good.
actually pretty good.
I do have one like thing that I need help with.
Yes.
When we print out all of those numbers and then like you guys started like multiplying stuff.
Sure, I'll run through that.
All right.
Good job, Parsa.